So hello everyone, welcome to GFG POTD playlist. This is Arnav, and today's question is check if subtree. So what does it mean? It means that you are given a tree and a small tree, and you have to find that if the tree that is rooted as root two, is a subtree of root one or not. So so that is the questions, and if you carefully read the problem statement of the question, then you will understand that the question what the question is saying. Let me read for you. Given two binary trees, root one and root two, each containing at most n nodes, determine whether tree S is a subtree of T3. So return true if S is a subtree of T, otherwise return false. That is the question. So a tree is and here it is written that what does it mean subtree? So subtree means, let me tell you what does it mean subtree. Subtree means that a root a tree has its left or right children as the tree. That is, a tree S is considered a subtree if there exists a node in T such that the subtree rooted at the node in I is identical to S. Two trees are identical if they have the same structure and the same node value. So if you carefully observe the first test case and the first diagram also, you can easily see that 3, 4, that is 3 and 4, this one is exist here. So this is a subtree of this node. That's why this is a true. This is returning true. And if you carefully observe the second test case also, uh, so in the second test case also, both root 1 and root 2 are identical. Why identical? Because 26, 26, 10, 10. You can see that each and every positions, both the tree has same node as well as same value. So that's why the both tree are identical. And if two tree are identical, so we can say that one is subtree of another because both are equal also already. So that is the question. So as you can see, this asked in different companies. This is a very important questions also. So first, like previous sessions, I will first explain you that how to approach the solution, how to approach the question, and after that I will go to the implementation part of the question. Okay. So first of all, let me copy this the input and output in the Google slide only so that I can explain in my way. Okay, so that is the question. So I hope you can see clearly. Let me, yes, okay, yeah, okay. I think it's okay. So the question says that the two root node is given, like 2, 3 is given, and you have to say that if root 2 is subtree of root 1 or not. That is the question. So you can you can make that if root 2 is subtree of root 1, if root 2 exists in the left subtree or root 2 exists on the right subtree, or the from the root where I is currently currently located. So from that root, whatever this tree is formed, that tree is actually root 2. So what does it mean? It means that there are three cases. What are three cases? There are three cases. Three cases are there. One case is the root to t actually exists actually exist in the tree, left subtree of root 1. Case 2, case 2 is what? Case 2 is the root 2 tree, root 2 tree actually exist in the right subtree, in the right subtree, or it can exist to this root only, to this root only. There are three possibilities exist. So how to check each and every possibilities? So first of all, we will go to how to check from the if the root 2 exists from this, how to check if the root 2 like exists from what? From uh, from this root only. So currently, assume currently I am in first node. Like currently I am in first node. Like first node means I am in node 1, and the root 2 is also in node 1. So first we have to check for the third condition, if the root 1 equal to root 2. It means if the root 1 value is equal to root 2 value. So there is a possibility that root 2 may be a subtree. Root 2 may be identical to current root structure. It means that if you carefully see the second case also, then the root, if we initialize root 1 or root 2 from 26 only, then there is a possibility, like I have said in the third case, that if the root 2 value equal to root 1 value, so there is a possibility that root 2 is starting from here, and root 2 is starting from here. There's a possibility. So that is I am saying, if root 1 value equal to root 2 value, okay, if this is the case, then there is a possibility. What is the possibility? Let's the root 2 tree, this tree start from here. So there is a possibility. So we have to further check that is this the case? Is this the case? So how we can check? We can check. We can check. We can check a boolean variable. Then check what is the case. Like I am giving any function that is a recursive function. It is a recursive function. Let's call that is memo, and it will take two argument. It will take two argument, and side by side, for your simplicity, I am also writing the code as per the intuition. Okay, so if the root 1 value equal to the root 2 value, okay, so there is a possibility that root 2 node start from here. Like root 2 node start from here, because root 1 value equal to root 2 value. So there is a possibility that also the left subtree, also the right subtree of root 2 also exist in the in this tree which suited at node 1. So we have to check further for the left subtree. Root 1 left, root 2 right. Okay, root 2 left. Okay, then we have to also check and root 1 right, root 2 right. Okay, so so this is I am saying, this is what I am saying, that if root 1 left equal to root 2 left and root 1 right equal to root 2 right, so it means that that there exists the root 2, there exists the root 2 subtree in the root 1 subtree also. But if this is not the case, so after that, if this is not the case, if not checked, it means that this is not the case. Then for that, we have to consider the left subtree also. We have to consider the left subtree. It may exist in the left subtree, so we have to consider the left subtree. Memo root on left, okay, and root 2, okay. So it can be a case. After that, if this is not the case, if this is not the case, then we have to check the right subtree. Check uh, the right subtree. Root to the right, okay. And for each and every this case, there are three possibilities. This is case one. This is case one. This is case two. Sorry, this is case three. This is case three. Sorry. This is case one, and this is, sorry, this one will be root to one dot right, and the later argument will be root two. Okay. Yes, this is quite clear. Yeah. So if this is not the case, if this is not the case, then so in the case, in this case, the check value is the actual answer of our question. So you have to just return check, return check. So that is the question. Yes. So if this check value is true, so the root 2 is subtree of root 1. If this check value is false, then this root 2 can't be a subtree of root 1. And because as we have discussed the three possibilities, and we have just written the pseudocode of three possibilities here, so that's why the all the cases are covered here, and after that all the calculation we will get the final answer as a boolean value that is stored in check variable. Okay, and we will return this check variable to get our to return our actual answer. That is the questions, and here I have written the just I have just implement that code. I just written the pseudocode here. So if check is equal to is subtree, like as I have said, I have just coded it here. So this is the questions. So here two cases are written here. Two cases are written here. Subtree. Okay. So that is the questions for today's. This is the today's question. I hope this is clear. If any questions arise, feel free to ask. See you in next questions. Next question. So till then, take care. Bye bye, and happy coding.